Good morning, everyone. I am Dr. A. Sedupati, Assistant Professor, Department of Mechanical Engineering, SNS College of Engineering, Coimbatore. This video will explains the slider crank mechanism and the principles and applications of the slider crank mechanism. Before going to this video, what is slider crank mechanism and where it is used and how the slider crank mechanism works. So the slider crank mechanism, its name contains the sliding movement. So what the equipment or parts will be slide using this mechanism. For example, we have a compressor. The compressor have a cylinder inside the piston, and the piston will be connected with the connecting rod one end, and the another end of connecting rod is connected with the crankshaft. So this crankshaft rotates, the connecting rod will be moving oscillate or up down movement, that is reciprocating movement. So this connecting rod is connected with the piston inside the cylinder. So the piston also convert the motion of linear, that is means reciprocating motion, up down motions. So the sliding mechanism used in the cylinder engines for compressor or automobiles or somewhere we are using in the internal combustion engines that will be using for the slider crank mechanisms. So the connecting rod will be moving up down. That movement will be created by the crankshaft. The crankshaft is getting only for the rotating motion. So the rotating motion is converted into reciprocating motion. So the sliding motion. So the name is slider crank mechanism. So crank is connecting rod, slider is a connecting rod and connected with the piston. So these both mechanism used in this slider crank mechanism. So the principle. So this presentation explores the fundamental principles. So we will cover practical applications of slider crank mechanisms. So these mechanisms are crucial in mechanical engineering. Almost the engines and automobiles, some of the equipments, for example, generators and internal combustion engines or automobile engines, compressors. So these are all using for this slider crank mechanism. So the principle of this is displacement moment. So the rotary movement is converted into displacement moment. So that is called kinematic analysis. So displacement, what is displacement? Examine slider displacement. So slider means the piston is connected with the connecting rod one end, another one connecting rod end is connected with the crankshaft. So the connecting rod movement is called the sliding movement. So displacement the piston from top end to bottom. So relate it to crank angle, understand motion characteristics. So what are the displacements it will be creating by this slider crank mechanism? And velocity. So that is analyze slider velocity, determine maximum and average speeds, consider factors that affect it. So how much velocity it will be creating. We will calculate velocity and acceleration diagrams for 4-bar mechanism or slider crank mechanism. So in this topic, we will calculate from this slider crank mechanism. So the velocity diagram used, how it will be worked in before video, I clearly explained. So what are the forces acting in the slider crank mechanism? That is called dynamic forces. So what are the dynamic forces created? First one is inertia forces, that is evaluate forces from acceleration. Consider component masses and crucial for smooth operations. So inertia motion is so many forces acting in the slider crank mechanism. These all forces converted into the one of the resultant force. That resultant force in dynamically create the opposite direction in the equivalent force, that is called the inertia force. This force is depends on the mass of the components and the direction of the motion. So the inertia force is an imaginary force that is created by the resultant force. This resultant force is created by the number of forces acting in the mechanism. So these all number of forces acting and converted into a one of the resultant force. That resultant force is creating the inertia force. So the inertia force is equivalent for the resultant force, but in the opposite direction. Then torque. Calculate torque requirements, determine motor sizing, and consider load characteristics. So torque is the twisting effect of the components. So that will be converted into the forces. Then balancing, that is implement balancing techniques, reduce vibrations and minimize wear and noise. So balancing is very important in this slider crank mechanism or any other mechanism. So the unbalancing components will be creating the vibrations and noise, also less efficiency and making more wear. So we will avoid unbalancing and using the correct balancing mechanisms. So what are the applications we are using in slider crank mechanism? So one is internal combustion engines, that is piston motion, I already explained. So convert linear piston motion. So the rotary crank motion is converted into linear piston motion. So transform to rotary motion found in engines. Then combustion process that link combustion to crankshaft, create power output, drive vehicle motions. Then engine design, that is optimizing mechanism geometry, enhancing performance, improve efficiency, that is created by the engine designs. Another example, that is compressors, that is reciprocating motion, use slider crank action, drive piston reciprocation and compress air or gas. So compressor is used to compress the air from atmospheric air. So we are using the piston cylinder mechanisms. Then pressure generation, so achieve desired compression, control output pressure, critical in industries. So we are using slider crank mechanism. Then system efficiency, that is enhance mechanisms, design, reduce energy consumption, lower operating costs. So these are all the efficiencies we are using in the slider crank mechanism in compressors. So what are the design considerations and what are the optimizations we are using in this mechanism? That is material selection, choose suitable materials and consider load, wear, temperature, ensure durability. So these are all the factors we are considering before selecting the material. And geometric parameters, that is optimize link lengths and affect motion forces and critical for performances. So these are all the geometrical parameters for selecting before designing the components. And lubrication. Lubrication is very important. It is reduce the friction force between the two surfaces. So apply lubrication strategies, reduce friction, wear, and prolong mechanism lives. So these are all the design consideration of the and optimization of the slider crank mechanism. I hope You understand what is slider crank mechanism? Thank you.